Hello, everybody, and welcome to another installment of the DI 101 webinar series. This series is an incredible resource offered to our customers, partners, and associates by partnering with our manufacturers and our industry experts. We will deliver informative presentations about industry trends, new technology, new products, and product applications. Today, we're extremely excited to partner with ArmaGel for today's webinar. Today's topic, ArmaGel will discuss benefits and applications of their new ArmaGel HT insulation product. ArmaGel insulation is manufactured to be more flexible and twice as thick as other Aerogel insulation blankets, bringing much faster application times, but still retaining the benefits of much superior thermal performance compared with other types of industrial insulation. Let me introduce our presenter from ArmaGel. Oliver Hills is the business manager for the Americas for ArmaGel Engineered Systems and has been with the ArmaGel Group for nearly 2 years. Prior to ArmaGel, he was with Owens Corning for 15 years, latterly as Director of Technical Services for foam glass insulation. He is also a professional engineer who previously gained 15 years of experience in the process industry, including time as principal engineer with the Rolls-Royce Industrial Power Group. We also have as a panelist Sandy Shaddles. She's the business manager for insulation for ArmaGel. We're proud to have ArmaGel present today, and we thank them for their time. We will pause for questions at the halfway point of the webinar and then again at the end. To submit questions, please use the questions tab on the GoToWebinar panel. You can submit your questions at any point during the webinar, and we will answer the questions during those two question periods. Without further delay, I will go ahead and turn this over to Oliver Hills with ArmaGel. Oliver?
Well, thank you, Jared, and thanks to DI for giving us this platform today. I want to talk to you about ArmaGel HT, as Jared has said, which is an innovative version of Aerogel for the market. And let me tell you a bit more about ArmaGel before I come to that. ArmaGel is a global company. We have 3,100 employees around the world in 16 countries and 24 production facilities. And we're headquartered in 3 locations, Chapel Hill for the Americas, in Singapore, and Munster in Germany. ArmaGel invests heavily in R&D, $10 million in 2018, compared with total net sales of $690 million. And our goal is enabling energy efficiency around the world. And we've been doing that for 55 years. You see that the company was originated in around 1860, but for the last 55 years, we've been concentrating on thermal insulation products, starting off with ArmaFlex, which we invented as the start of flexible elastomeric foam insulations way back in 1954. The ArmaGel Engineered Systems is a part of the ArmaGel Group, and we were created to be 100% dedicated to the oil and gas industry, providing service to the engineering, procurement, construction companies, the installation contractors, the owners, and the operators. And it's our goal to be in close relationship with all those stakeholders, really helping them to define and install our products. What do we do? Well, obviously we produce thermal insulation, and that's both flexible elastomeric foam as well as aerogel blanket. But we also are very well known for acoustic insulation systems, which incorporate those thermal products. And we have systems which are thinner and lighter than the traditional products within the industry. And I'll talk a bit more about those later on. But we also produce jacket products to give mechanical protection to insulation systems, and of course a wide range of accessories and fixing materials, adhesives and sealants and so on, to make those systems complete. There's one standard that is used globally to define aerogel blanket products, and that's ASTM C1728. That is the gold standard for aerogel blanket products. Now, our ArmaGel HT meets the ASTM C1728 Type 3 Grade 1 category A. And the requirements are listed in the table that you can see in front of you now, which covers things like temperature use, simple things like thickness and density, but also surface burning characteristics, water absorption, effects on stainless steel for corrosion, a wide range of things. And ArmaGel beats or meets all of those criteria so that it can be absolutely considered to be meeting the Aerogel standard. If a client says that they want Aerogel meeting ASTM C1728, then ArmaGel HT meets that. The only additional thing is regards to thickness and regard to tolerances. I'll talk a lot more about that later on, but when the standard was originally written, there was only 5 and 10 millimeter aerogel available, whereas now we're bringing product that is up to 20 millimeter thick within a single layer. So quite a considerable improvement on what started out. The test results which show compliance with ASTM C1728 are available in our technical guide, and all you need to do is contact us and we'll send a copy of that guide out to you. So you have a complete set of the test certificates within there showing that compliance. Now, when we've spoken to companies like Chevron and Total and Shell and Dow, they're not actually looking for a brand name on aerogel blankets. They're looking for aerogel blankets which comply with ASTM C1728. So they said to us, hey, you comply with that, that's good enough for us. And that's a very important thing to be aware of. So let's dig a little bit deeper into ArmaGel HT. As I've said, aerogel blankets are highly efficient, and again, I'll talk more about that later, but we've produced some step changes with this new generation of aerogel blankets named ArmaGel HT. We create a dedicated aerogel powder, which we inject into our blanket, which creates a blanket that has better flexibility, a greater available thickness, and better protection against corrosion under insulation than alternative aerogel blankets. That really makes ArmaGel the best available aerogel blanket for ease of application and for performance. Those properties in particular are very, very good thermal efficiency, excellent sound attenuation. As I said at the start, you can reduce the thickness of acoustic systems, and that's quite significant. It's super hydrophobic, and for all of those who are concerned about corrosion under insulation, we're really worried about how do we keep water out. Well, it is very, very water repellent, and again, you'll see that later on. And being made of inorganic silica and glass fabric, it has very good fire resistance. So just to summarize the key characteristics of ArmaGel HT, it's a silica aerogel blanket, grey in color, and has a service temperature range of -40 to +1200 Fahrenheit. As I said, it has approval compliance to ASTM C1728 Type 3, Grade 1A, and a density of 10 to 15 pounds per cubic foot, and available in thicknesses of 5, 10, 15, and 20 millimeter. And we supply it as sheets in roll format. When it comes to producing aerogel blankets, for quite a few years, there was only one real way that they were made, and that's shown on the right. And that's a batch process. You have various pressure vessels into which blankets are dropped and then treated. So there are time-consuming elements to it, and it's more difficult to get an even penetration of the product through the blanket and an even thickness of blanket. Compare that with the way that ArmaSol makes the ArmaGel blanket. This patented process is a continuous feed process. So we inject the aerogel into the blanket using hexane as a carrier, and then we dry the blanket. What that does for us is we have a very, very consistent blanket thickness, so that it's not thinner at the edges, it's not thinner in the middle, just good consistency, and that's important for the thermal performance that you're looking for. So that takes us into looking at that thermal performance, and let's do some comparisons. Here's a graph of thermal conductivity against temperature. And the higher up the graph you are, the worse the thermal conductivity. And the further to the right you are, the hotter the temperature. So you can immediately see that thermal conductivity tends to increase with increasing temperature, but some materials increase faster than others. So for example, the blue line is cellular glass. The grey line is mineral wool. You see quite a steep increase in the gradient of their curves as the temperature increases. In other words, the thermal performance rapidly becomes worse. But the green line is for ArmaGel HT. And as you can see, it's far, far lower thermal conductivity than those other common materials that are used in industry. And that means that the insulation itself can be a lot thinner. To see how that really looks on a pipe, we've got a 6-inch pipe sitting at 572 Fahrenheit, and we've got a heat loss target of 156 BTU per foot hour. That would take something like 6 inches of expanded perlite to reach that heat loss target, or 5 inches of cellular glass or calcium silicate, even 3 inches of mineral wool. But with ArmaGel HT, only 1 inch would be needed. That's an enormous reduction in overall thickness. And less thickness means less weight. It means less product to carry around site. There are a lot of associated benefits with that. Just to show you the curve from the ASTM standard, the blue line is the ASTM, what you have to meet. Competitor blankets meet that, we meet that, of course, otherwise we wouldn't be able to sell it as compliant with ASTM C1728. But what's quite interesting is as the temperature increases, our thermal performance relative to other aerogel blankets gets better. So we have a very high performing blanket, particularly at those elevated temperatures. And another comparison, again, on a similar pipe with similar circumstances. Perform the calculations, and you can see that 60 millimeters of aerogel blankets required to fulfill the heat loss requirement or the personnel protection requirement. Okay, we can put that on in just 3 layers, 3 20mm layers. But there's something in the ASTM that not a lot of people have caught sight of. It gives a tolerance of plus or minus 25% is allowable on blanket thickness. So in other words, if you put 6 layers of a 10mm blanket around that pipe, you would expect that you'd get 60mm total thickness. In reality, if you're at the lower end of that acceptable thickness range, you could have 15mm less, or 3/5 of an inch less on the overall thickness. That's substantial. That changes your expected heat loss from 90 BTU per foot hour to as high as 113 BTU per foot hour. Imagine if you set the personnel protection temperature based on 60 millimeters of aerogel blanket, and suddenly you find that you have 45 millimeters on there. Suddenly you've got a dramatic increase in the surface temperature, and that's a burn hazard. So when we produce our ArmaGel blankets, just to reiterate that, we have a 0 minus tolerance. In other words, if you order a 10mm or a 20mm blanket, you get at least 10 or at least 20mm of thickness. You don't get less than that. We made a very conscious decision that the tolerances that the typical customer would expect are going to be far better than plus or minus 25%. And the reason that we can control those tolerances better is the nature of our production process. As you see from the end of this blanket here, we've got a very consistent thickness. It's not varying across the width or across the length of the blanket. That means that when you put your metal jacket over the outside, you're not seeing undulations within the jacket. You're getting a very consistent appearance to everything and a better installed job. We hear a lot of talk about something called thermal shift, and in the marketplace there's not a lot of understanding necessarily of what that really means, but it's put forward as maybe a risk factor for insulation materials that have to go to high temperatures, and particularly those who have to go through cyclic conditions. So we thought it was important to test our ArmaGel blanket. And so we sent it to the renowned institute, FIW, in Germany, who typically do a lot of the thermal conductivity testing for many manufacturers around the world. A 12-inch pipe was insulated with multiple layers of ArmaGel HT and sat at 1076 Fahrenheit for 3 months. The temperature between each layer and on the surface was measured throughout that time. At the end of that test period and after some cycles, the temperature at each of those layers was unchanged. So in other words, there was no thermal shift, no evidence of thermal shift at all over those extended high temperature and cyclic conditions. So if that question ever comes up, there is data to back this up, and we'll be happy to talk about that with you. Well, what about installation? Are there any benefits with an ArmaGel HT blanket when it comes to trying to install it compared with other insulation materials or even other aerogel insulation materials? Well, the answer is yes. For a start, having thicker blankets, 5, 10, 15, 20 millimeter thick, rather than the alternatives that are available on the market that are just 5 and 10 millimeters thick, means that they can be installed faster. It might be as much as 2 times faster. That's up to the contractors to decide how fast it can be put on and what their logistic efforts are. But for sure, it's going to be a lot faster to install a blanket that's twice as thick than one that's only half as thick. And of course, less layers will mean time saved. In this particular example, we have a requirement for 30 millimeters of ArmaGel, where that can be installed into 15 millimeter layers or a 20 plus a 10 millimeter layer. Aerogel blanket from others would have to be installed in 3 layers of 10 millimeters, so 3 layers instead of 2 layers. Or if you go to an alternate product, for example, cellular glass for the same thermal conditions, you would need 3 layers to avoid such things as thermal stress cracking. So 2-layer application instead of a 3-layer application, that's a real benefit for installation. Another factor that comes out when you reduce the insulation thickness is clearly you have less material around the pipe. And if you have less material around the pipe, you have less weight. So in green, you can see the total insulation weight in pounds per linear foot. With an ArmaGel system compared with mineral wool or cellular glass or calcil or expanded perlite, the ArmaGel system comes in at a lot less insulation weight. But a factor that people sometimes forget is that if you have less overall thickness, therefore less diameter, you have less circumference around the outside of your insulation. And that means that you have less jacket, less steel or less aluminum wrapped around the insulation, and therefore the weight goes down. So you can see those little blue rectangles getting thicker and thicker as the diameter increases. So that again is another significant saving that can be made to the weight of the installed system. And that can be particularly important when building modules or offshore platforms. A thinner blanket than certain types of insulation, and certainly a more flexible blanket than other types of aerogel blanket, makes installation easier. It's a lot easier to wrap around the pipe and to wrap around fittings than traditional aerogel blankets. And ArmaGel is very easily manipulated, even at the maximum thickness of 20 millimeter. The additional benefit that perhaps we didn't expect early on was the ability to wrap thicker layers around smaller pipes. In other words, rather than putting multiple very thin layers on to cope with a small pipe diameter or having to V-groove the aerogel blanket, the blanket can simply be wrapped around without causing problems for installation and creasing. So for example, a 5 millimeter blanket can be wrapped around a 1-inch pipe, and a 20 millimeter blanket wrapped directly around a 4-inch pipe. And that really is a very considerable difference from working with stiffer products. The video that you're seeing is a little bit choppy, and that's unfortunately just part of the platform that we're transmitting on. but hopefully you can see what happens when the guy starts to cut it. This is the first time that a contractor has seen the ArmaGel blanket. It's in Canada as it happens, and hopefully the guy won't lose his fingers there, but one straight cut across the blanket and he can pull off a piece of the blanket with a clean edge. He's not having to make multiple cuts. And again, that's due to the nature of the way that the aerogel is incorporated into the blanket. And if the audio was on, you would hear how they were very surprised at how easy and how clean that was to cut. Another great benefit of flexibility is how to insulate fittings and elbows and bends. So for example, down in the bottom right corner, you can see multiple segments shown in pink. That's the traditional way of doing some of these elbows. So for example, a 10-inch long radius bend would need something like 9 segments to go around it. Well, that same bend can be insulated with just a 2-piece fitting made out of ArmaGel. There's much greater flexibility. It allows that fitting that you can see in the top right just to be fitted straight around, and that saves time. So in the trials that we had, that gave a 61% saving on time compared with the multiple segment fitting. Not only that, you've got a lot less straight through joints. And in any insulation system, minimizing straight through joints is one of those important things for reducing heat loss and reducing hot spots. So the 2-piece ArmaGel bend makes a significant difference to that. That gets us to the end of the first part, and we're now ready for some questions, Jared.
Thanks, Oliver. We don't have any submitted as of yet, but we'll just pause for a few seconds and see if any come in. Again, if you would like to ask a question, just simply type it in using the questions tab in the GoToWebinar control panel on your screen. So we'll just pause for just a couple seconds and see if any come in. Looks like we have one from Francisco. He says, "Good afternoon. How dusty is it compared to other brands?"
We've done some vibration testing, and there are some standardized tests to compare mass loss, for example, due to dust release, and we found it to be comparable to traditional aerogel blankets.
Excellent. And we have another question from Jonathan. He says, "What are the roll and sheet sizes, and do you have any examples of removable pads with ArmaGel?"
The second part of that is quite easy to answer because there'll be a picture of that coming up later. So the answer is yes. Removable pads or removable blankets have been produced, and that's certainly something that could be taken up by a manufacturer in the US. Certainly in the Far East, that has happened already. The blanket sizes, we have all of that information on the data sheet at the web address that will come up at the far end of this presentation. So that's probably the easier way to look at that.
Thank you.
And we have one more from, he says, have you used it in a wastewater industry?
I am not, certainly within the marketplace that I look after, I haven't seen that yet. There's no reason why not, and I'm sure that aerogel blanket products have been used there in the past. My personal main focus would be oil and gas and petrochem rather than directly to wastewater.
And we have one from Chad. Is there a difference in thermal performance with 3 layers of 20 millimeter versus 6 layers of 10 millimeter, for example?
The main criterion that you would normally be looking at is gaps in the insulation, in other words, where the 2 edges butt up. When you have as many as 6 layers or as many as 3, that's generally not considered to be much of an issue. If you only had 1 layer around, then certainly within European standards that I used to work with, there was a factor always added to allow for the fact that there would be a straight through joint. If you've got a couple of layers on there, then that factor is really going away. So by the time you get to 3 layers for sure, I would not be worrying about that.
Great. We have a question from Carl. Can you please explain a bit about thermal shift? And he also asks how it's comparable to conventional and hydrophobic. He has MW. So.
Mineral
wool. Yeah, mineral wool.
Yeah, I guess there are 2 issues there. There's the absolute thermal conductivity, and does that change with elevated temperatures on hydrophobes and resin binders? And the other is the effect of whether or not they're still as water repellent, and whether that then has a knock-on effect on thermal conductivity. So slightly different issues, or on corrosion under insulation, for example. For thermal shift, there's no significant or no measurable effect on thermal conductivity due to the hydrophobes being affected by temperature in the testing that FIW did. On mineral wool, I cannot answer that question as to, I've not seen the test results, so I don't know how mineral wool would perform in terms of thermal shift. When it comes to things like corrosion under insulation, then the presence or not of hydrophobes may or may not be important, and I'll show some pictures later on as to why I'm saying that, and hopefully try to explain that a little bit better. Sorry if that's not a complete answer, but certainly happy to take that one up afterwards and try and put some more detail into it if that would be helpful.
Great. I have another question from Troy. He says we get a lot of pushback from labor regarding health concerns. Can you address these concerns?
Yeah, sure. Certainly, change is not always popular with any difference in insulation material. People are always very concerned about what's happened in the past, obviously with asbestos. And so there's always a question in people's minds as to whether or not there is a health hazard with any new product, and particularly a product like an aerogel type of product, where you have hydrophobes in there and people feel the water repellency of the hydrophobe if they get it on their skin. So they wonder, hey, is that safe or is that not safe? There's been extensive testing of this product. Some have said it's one of the most prodded and probed products that's come onto the market in the last 10 or more years. And I think that's probably right. Certainly, we have seen no evidence through our research that, if correctly handled, that this is a health hazard. There are simple precautions to take to avoid the nuisance dust. So, for example, just wearing face mask to prevent breathing it makes life a lot more comfortable. Keeping it off your hands with gloves in the normal way. And that's all covered in our safety data sheet, which again is available on the web address that will come up at the end of this. So from a handling point of view, I think it's also fair to say within ArmaGel, we take that especially seriously. And of all the companies I've worked for, the attitude towards safety is very, very good within ArmaGel. So personally, I don't have any worries about working with the ArmaGel product.
Thanks. We have one more, and then for the sake of time, we'll move on because this is just the halfway point. And so if you have any other questions, submit them, and we'll get to those at the end. This question is from William. Are you still able to band metal on this product without the OD changing, creating gaps in the lapes of the protective jacketing?
We've done, certainly last year, I did quite an extensive range of compression tests on ArmaGel HT and was comparing it with competitor products, putting jacket around it and banding essentially to destruction until you couldn't band any tighter without destroying the buckle. And I found the performance of ArmaGel HT fully equivalent to other products on the market. So that's probably the best way to answer that question. For sure, if you have a very, very thin gauge jacket and you band it excessively tightly on any product, whether it's wool or a different type of aerogel product or ArmaGel, you're going to see some effect of that band. But on a like-for-like basis, then I don't believe that you'll be seeing that.
All right, thanks, Oliver. I think we can go ahead and move on to the second half, and we'll get to some more questions at the end.
Okay, great. Thanks, Jared. Well, next I want to talk about corrosion. And what we found, we expected a good result for corrosion under insulation testing, but we have found far better results than we expected. And I'll show you those results and I'll explain why some of that is happening. For a start, hydrophobicity is important to keep the water out, and I'm hoping that the video is not too choppy and you can see what's happening. Just pouring a bottle of water over the top of the insulation and it's just beading and disappearing off the side. So from that point of view, for keeping liquid water out, it's fantastic. We've also done a variety of testing for various corrosion processes and situations. So one of those was testing for leachable ions using STMC 871 methodology. And the diagram that you've probably seen in a few documents before and was published in STMC 795, the red zone on the left is where you do not want your results falling for parts per million of chloride and fluoride. The green zone is the acceptable zone. And basically, if you're in the red zone, you're at risk of stress corrosion cracking. If you're in the green zone, then that risk is mitigated. And ArmaGel, those two blue circles there in two different tests, is well within the green zone. So that's great. Also, the pH value is slightly alkaline or basic. And again, that's good for mitigation of corrosion under insulation. You don't want an acidic product against your pipe. We were so interested by corrosion results that we commissioned Incoa, which is an independent surface substrate engineering company who specializes in corrosion under insulation, to run some tests. And what they did, they put an environmental chamber, which they set at an elevated temperature and humidity, 95 Fahrenheit and 80% relative humidity. They put some carbon steel pipes in, they connected those in series and flowed through them fluid ranging at temperatures from 41 to 176 Fahrenheit, changing daily. So in other words, a daily cyclic episode. They insulated those pipes with different materials and they pierced the insulation halfway through with a 1/4 inch hole and then just let it go for a couple of months and to see what happened. So basically, when you're in the high humidity, warm environment and the pipe goes cold, you get vapor traveling towards the pipe, you get condensation forming on the pipe, and everything heats up inside the pipe and that water evaporates. So you're creating a cycle that's kind of the worst case for corrosion under insulation. So after that 65-day test period, they disassembled and had a look to see what had happened. On the left, there's stone wool or mineral wool. And Incoa's statement was that there was 5 to 10% corrosion across that pipe. And they gave it a protection rating of 3. And their protection ratings, which is according to an international standard, range from 0 to 10. And 0 would be the worst and 10 would be the best. Cellular glass, often chosen to try to mitigate against corrosion under insulation. Incoa said that there was increased corrosion in the area of the seam and that the area of rust was 1 to 10%. And they gave it a protection rating of 3 to 5, again, against that ISO standard. So still at the low end of that protection range. The competitor Aerogel was tested, and Incoa said there was corrosion all over, and the area of rust was 10 to 25%. We did not expect to see that. We expected that result would be a good result, but it wasn't. And so we did a bit of digging to find out why that would be the case. And I don't know how well you can see it, and I'll try to use my mouse to show it. You see some lines going across the pipe. And as far as we can gather, those lines follow the lines of the creases in the blanket. So it was a stiff aerogel blanket that didn't form fully around the pipe. It didn't have an intimate contact with the pipe and created creases, which then led to voids underneath. So in other words, the humidity comes through the blanket, condenses on the pipe when it's going through a cold cycle, and lo and behold, you get some corrosion occurring in those locations. That was a very, very interesting thing to observe. Two different ArmaGel installations were also observed, one with ArmaGel and a layer of ArmaFlex flexible elastomeric foam over the top, and on the right, just with ArmaGel, 2 layers of ArmaGel. And just in passing, the circle on all those samples represents where there was the hole introduced into the insulation system. And in both cases here, Incoa said no corrosion, 0% rust, and a protection rating of 10. I mean, that's phenomenal. We were both surprised and very delighted to see the degree of protection. Part of the reason for that is, of course, you have a hydrophobic product, but with ArmaGel, you have a very flexible blanket. So the blanket molds itself around the pipe without forming creases. So in other words, there are no voids. It's not forming around the pipe like a hexagon, but it's absolutely following the line of the pipe. So that means that there's nowhere for condensation to form other than in the hydrophobic blanket. And if it did that, it's rejected out, not towards the pipe. I said I was going to talk about acoustic insulation. And again, this was quite a good surprise for us. We have a variety of systems to meet the 4 acoustic classes that generally are talked about. So there are international standards and there are Shell standards that define different acoustic classes. And going from A to D, D gives the greatest level of acoustic protection, the maximum decibel reduction. So the simple system that you see on the left is a layer of ArmaGel blanket, layer of mass-loaded vinyl, and then a jacket on the outside. And on the right-hand side, we have a little bit more complexity, but still the same ingredients, layers of ArmaGel, mass-loaded vinyl, and metal. So that's the basic build-up of the system. Simple to install and straightforward to understand on site. But the really astonishing thing is the difference in overall thickness compared with the traditional system, which is mineral wool. And particularly in that class B2, you see that to achieve the acoustic result needed to kill the sound in the pipe so that everybody working around it or living around it is not bothered by it, it took 4 inches of mineral wool and other components. And with ArmaGel HT, just a simple 1 inch to achieve the same result, so a quarter of the thickness. And that's an astonishing difference, and that means that the system is going to be considerably lighter, the system is going to be considerably thinner, and so you'll have a lot more space within the pipe racks, a lot more space for access. That's a really great result. And the same with all of the other systems that we're showing there, the A, B, and the C, and the D systems, still considerable saving in overall thickness. Now for some references. We launched the product last year, so although the concept of aerogel blankets has been around quite a long time, we've been starting to gather references since then, and here are a few of them. This project was in West Virginia. I went to see this project and to help out. They were insulating live lines, steam lines at 360 Fahrenheit. They didn't switch off the system, so that was a little bit tricky to start with. 83,000 square feet of ArmaGel blanket was installed around these pipes. Here's a refinery reference from Korea, 40 millimeters of ArmaGel HT. Again, another live installation onto hot steam lines. Now, we didn't install this. That was the local contractor of the site. The normal system on the site was 3 inches of e-glass, and that was replaced by 1.5 inches of Aerogel. On the left, there's competitor Aerogel, and on the right, ArmaGel HT. And looking at the left, it's not the most beautiful job in the world, but I think part of that is probably coming from the stiffness of the blankets. But we didn't install it, so we can't take the blame for that one. At Petrobras refinery in Brazil, operating temperatures up to 662 Fahrenheit on sulfur removal and SOx reduction, 50 to 60 millimeters of ArmaGel were installed. So very, very nice looking project as well. And the question was asked earlier about removable blanket products. Here for Wanhua Chemical, they were looking for an acoustic blanket system for turbine compressors, and 50 millimeters of ArmaGel HT was stitched into the blanket to be wrapped around the system to provide noise reduction. And the last example I want to show you was our first project in the US. It was a very small project, but it was at the Wright Brothers National Memorial. And basically they'd installed their pipes, and whoever had done their thermal calculations, or maybe they didn't even do the thermal calculations, but whoever had arranged for those pipes to be installed had put them far too close together. So basically they couldn't put insulation around them and achieve what they needed to achieve. So our ArmaGel HT 20 millimeters thick was installed around those pipes so they could deal with the tight clearances that they have. So thickness reduction, whether it's because of access like this, where the pipes are too close together, or whether it's to reduce the size of a skid, for example, all of those can be quite considerable advantages for using ArmaGel insulation. And to give you an idea of how we work within the US, for engineered systems, there's myself and Mike Rodosty, who's particularly responsible for business development of the ArmaGel product. He has a great many years experience within the aerogel market, selling aerogel products. So if there's anything you want to know about how to use them, Mike for sure will be able to give you the answer to that one. But we also have a dedicated technical support team who will run any thermal calculations for you or make assessments for you. And also a US-based customer service team who work for Sandy Shattles. And together with local distribution partner, DI, we'll get that product to you. But when you get to site, we have a team of global application specialists who are ready to come out and give training before installation, supervision during installation, whatever you want, they're willing to help with. And it's up to you how you want to use that facility. When our application specialists come out, this is one of the things that they'll bring with them, the ArmaGel HT application manual. Many installers will already know how to work with aerogel blankets. It's familiar to them. The application manual gives a few more details in terms of how to band or how to wire, when to make those choices, and a bit more installation information just as backup. That booklet is the basis of either a half-day introduction or a 2-day detailed training, depending on the needs of any particular contractor. So just to summarize what we've been talking about, ArmaGel HT is available in 5, 10, 15 and 20 millimeter blankets. It's compliant with ASTM C1728, which means it's good to go on pretty well most facilities who've ever used an aerogel blanket. It would be suitable for them without any additional complication of trying to get through the approval process. It gives better corrosion under insulation protection than other comparable products. It gives a very compact acoustic system and will provide whatever technical support you want to achieve the right solution. And at the end of the day, it gives you the potential to save on installation cost through thicker blankets and more flexible blankets. So information on data sheets, safety data sheets, is available at our website, armacell.com/ArmaGel, and it gives you a choice of making a difference in the way that you install aerogel blankets. Over to you, Jared.
Thanks, Oliver. We have a couple questions. We have one from Troy. I tell you what, before I get to the question, just do want to remind everybody that we are drawing for the grill that you might have saw. So we will do that at the very end. So please hang with us at the very end, and we'll draw for that. We have a question from Troy. It says, is there a preferred method for CNC cutting on your product?
Yeah, and WaterJet cuts it extremely well. I've also found that other fabricators using more traditional methods have been able to cut it well, but the best results that I've seen have been with WaterJet.
And Jonathan asks, fiberglass board has good acoustic properties. How does that compare?
Yeah, typically any of the either glass wool or mineral wool products will be considerably thicker than ArmaGel. And I've not got a great amount of previous experience of the glass wool board, but I would say you're probably heading towards the thicknesses of mineral wool, which, as we saw in a Class B2, was 4 times thicker than ArmaGel.
And the next question, what are common lead times and product availability? In that,
sorry, yeah.
I was just going to say that might be a question for your local DI rep as well, but from your end, Oliver, I'll let you go ahead and answer that.
Yeah, for sure. DI have taken ArmaGel into stock, and we also have extensive stock in one of our storage facilities in the US. So that route to market has already been established and ready for action.
And another question says, I can't find a US safety data sheet on your website, only a European document. So, you can answer that, but one thing I was going to say is, Oliver and Sandy, if you guys, I don't know if you have a slide with your email addresses, but if you want to throw your email addresses in the chat box for everybody to grab so that they can maybe reach out to you after the webinar if they have any questions or requests like this, but I'll let you go ahead and answer that one as well.
Yeah, that would certainly be great if we could pop that into the chat box. The safety data sheets have to comply with the global harmonized standard now, which in theory at least means that they are meant to be identical globally. I need to check back. I believe that there is one produced for the US market, obviously in letter page size, but essentially covering the same things. So on the global harmonized standard, it requires that every section is given the same section number and title that you would have, whether it's in Europe or Asia or the US. And that came in about 5 years ago. So if there's anything that is a concern that's not covered by that safety data sheet, then by all means contact us and we'll see what we can do to sort that out.
Next question. Jonathan asks, is this product available at DI in California? Sandy, you might be able to answer that, but if not, Jonathan, in this case, I would recommend you probably reaching out to your DI branch or your DI representative, and they can fill you in on that, or Sandy might be able to as well.
Absolutely. No, thank you very much for your interest in California. That is definitely a target market of ours as well with DI. We are establishing which regional locations would be best to supply from with Distribution International. Right now, it is all originating out of the Texas facilities with plans to extrapolate that out to the rest of the regions out there. But we can get it to California, no problem. So definitely reach out to your DI representative. And Jared will be, he actually just shared my email address as well. So if you want to shoot me an email, I can definitely make sure we get you in touch with the right person.
And let's see, looks like the last question I have, you mentioned about 1/4 inch perforation insulation in the slide showing corrosion under insulation testing for 65 days. I have two questions. Is this test method as per some ASTM? And two, no corrosion was observed even at the location of a 1/4 inch perforation with ArmaGel. Is there any reason for that?
Yeah, for sure. The procedure, to my recollection, was put together by Incoa with their expertise. I'd have to check into that. I don't know whether there was a standard at the back of that. So I'd have to come back to you on that one. The 1/4 inch, well, I know for sure that the major objective that they were tasked with was that the test would be as near as we could represent to a real life scenario. Now, everybody's real life scenario will be different from the next guy's. I get that. But dealing with a humid atmosphere, which causes condensation on the pipe where, for example, water might not travel through, but humidity would, that was all part of making that test as difficult to pass as possible. The 1/4 inch hole penetrated to half the depth of the insulation material. So in other words, if there was a foil on the outside, like there would be for cellular glass, for mineral wool, that foil was pierced. And then, as I said, halfway through the total thickness of insulation, that 1/4 inch hole went. When you have a product like Aerogel, the ArmaGel blanket in particular is super hydrophobic. So you would not expect liquid water to go through, but we're not actually testing for liquid water. There's no continuous rain shower in this test. And as I said, the reason for that is that humidity is more challenging than rain. And indeed, if you're trying to do an extended test with a hole through an insulation material, we have a constant salt rain shower, for example, you soon find that the salt starts to block up the holes because of the nature of the test, and then the test starts to become unrepresentative. So humidity is a very good way of doing this. And whether you are going through one layer or two layers of ArmaGel with that hole doesn't make much of a difference. If you went straight through to the pipe, then we would expect to see and have seen in other testing that any negative effects are very localized to that hole. But that wasn't the objective in this test. It was the kind of damage you get on a job site. The insulator maybe sticks his knife or a piece of welding rod or something else into the insulation just as somewhere to park it while he goes and does something else. I've seen that happen so many times. That's the kind of damage that this was meant to simulate.
Thanks, Oliver. I think that's the last question we have come through. So just in closing, I just want to just a few quick comments. First of all, Oliver, I want to thank you so much, both you and Sandy, for your time today. This webinar series is really not so much meant to be a bunch of sales pitches, but really meant to provide DI customers with information that helps make their job easier. And I think, Oliver, you did that today with a lot of great technical information, so I thank you for that. If you have, for our DI customers, if you have interest in this product or further questions about this product, reach out to your DI representative or your local DI branch and express that interest to them, and they will be more than willing to help you and provide that great service to you. So with that, I think it's time to draw for our winner. So Sandy, if you could, and just so everybody knows that DI, I know there's some DI associates and also supplier partners that are on the call. So you guys are not eligible, only DI customers. So with that said, Sandy, if you could pick a number between 1 and 40, and I will find the closest DI customer to that.
All right. The lucky number is 7.
Let's see, that would be Brad. Brad, I'm not going to give your company name away, but there's only one Brad on the list. So, Brad, I will reach out to you by email and make arrangements. Congratulations on a new Pit Boss pellet grill. So, and
Congratulations.
thank you to ArmaGel for sponsoring that giveaway as well. So we appreciate that. So follow us on LinkedIn. You'll see posts for upcoming webinars. We are going to do at least one of these a month, and they will vary between all kinds of topics that hit all different industry segments and products that DI offers. So again, thanks to ArmaGel. Thanks to everybody that attended. We had some great engagement today, and we will see you on the next DI 101 webinar.
Great. Thank you, Jeremy.
Thank you, guys.
Thank you.